Welcome to our meeting tonight. The topic for tonight is the mind of the universe, and we have with us tonight Dr. Francisco Diego from UCL. So tonight's talk, The Mind of the Universe, Dr. Francisco Diego. Many of you will recognize him from various places. If you might have seen him here before, but you more frequently have seen him probably on television. He has been to us previously. 2012 he talked to us about where are all the aliens. That was based around the fact that, you know, there's so many star systems out there must be planets and must be aliens living on it and so on, Drake's equation basically. And then 2014 he did an astronomy workshop, not for us but for the school itself, and that was a very successful workshop and lecture, feedback from the people at the time. Then 2015 he came back to us and he said, his title of his talk was Captain, It's a Ghost Universe Everywhere, referring to the fact that the visible universe that we can see with all the most amazing technology we've got only accounts for something like 4% of the mass of the universe. So that was why it was called a ghost universe. So born in Mexico City, he was a mechanical engineer originally, and then came to UCL in 1982, and that's where he got his PhD in astronomy. Currently, he's a lecturer at UCL's Department of Physics and Astronomy, and he's a VP of the Association for Astronomy Education. He's a member of the AAU and a fellow of the Royal Astronomical Society. He's well known as being a promoter of natural sciences, and some of his talks include references to that. He's also an experienced planetarium producer and presenter. He's a lecturer, an author, and a broadcaster. You may have seen him on different programs on television, Stephen Hawking's Universe, BBC, The Planets, BBC, The Wonders of the Universe, Genius by Stephen Hawking, 7 Ages of Starlight, The Secret Life of the Sun. The list goes on, and he's been interviewed numerous times on various other programs as well. But he's the founder and director of Your Universe, which is the UCL's Festival of Astronomy. He's producing and delivering The Mind of the Universe, a collection of these public works and school lectures, teacher and workshops in astrophysics, cosmology, and the life of the universe. I'll just drop that back a bit. There we go. So he's also had a project called Paradise Planet Earth. It involves all levels of education and public outreach, blending the natural sciences with the arts, philosophy, and ancestral wisdom. And I think he's got that prop with him here tonight. Yes, it is. And the main thing is inspiration to face the global environmental and societal charges that face us already growing out of control. So it's a mixture of things. So we're going to switch over to Francisco now. If he can make his way to the stage, we'll swap over his laptop for ours. So please welcome Francisco.
Thank you. Yes, thank you. Thank you very much for that introduction. I completely forgot all about that. Before I start, let me tell you I have some experience with, of course, telescopes and planetariums. So I would like at some point in the future, near future, have a look at the planetarium here in the school and see what can be done. If I remember well, it's a size Mark 4 or something like that. It's a single ball or something like that. If I remember, I saw it once. But I will be very happy to help. And also, there are people in the observatory that are very good technicians that could help with that. Just think about that. Because people, what we call normal people, are not like that. Children are like that. And this one. It's not so much about memorizing, it's about feeling, it's about emotions. It's about what you feel when you see a lunar landscape on the telescope, live image, as we do all the time. I want to give you a tour of the nature and development of the universe very quickly. We know all these things, but I want you to feel them as well. Because we look at our landscapes everywhere, and they are fantastic, and we start asking questions. When we see all this, where is it coming from? Has always it been there? And then we come a long history with these creation myths. In the absence of proper evidence, we still want to have an answer. We make it up. And we have a beautiful creation myths, very imaginative creation myths, a long history. Shu and Geb, Shu and Tefnut here in the atmosphere. Geb becomes the earth, the goddess Nut with her body covered with stars. Isn't that beautiful? And we see her when the sky is very clear. You can see Milky Way, the goddess Nut. Tawa, the sun god, the spider woman, the earth goddess from North America. The rainbow serpent, the creator of the world with plants, animals, and humans eventually populating that world. Our part of the world, the Genesis, talking about a God that creates the entire universe, including humankind, in a few days, and brings a paradise where all the life can exist. In this beautiful paradise, I will come to this picture again, lovely picture. This one is the Apache. The Apache said, in the beginning, nothing existed. No earth, no moon, no sun, no stars, no sky. Only darkness and silence were everywhere. Amazing intuition, because that's exactly the case, as far as we can tell, according to the evidence that we have. And I'm going to leave you with this couple of paragraphs, similar to the ones we saw before, about looking at fact with the mind of a little child without any preconceived notions. Just look at what is there. Don't try to, just look at what is there. So, give preconceived notions, and then humility is one of the most important parts of humanity, and humility is really, really lacking everywhere in the world, almost everywhere in the world. We need to be more humble towards ourselves, towards the environment, towards nature. Nature is by far more powerful than we are. It was here before we us, it will be here before, after we leave. Let me give you a few analogies, because I would like you to, perhaps you have seen this before, to repeat these analogies when you go to the public or to your families and friends. The power of analogies. Lot of water. What is the smallest amount of water we can imagine? This time of the year, with the spider webs full of, especially in the morning when we have this fog that condenses in the spider webs. Look at the scale there. What is the smallest amount of water we can get? And then we come to the concept of the water molecule. There are color codes here. I will come to that. The red is oxygen, the white is hydrogen, H2O. And this is the analogy. How small are molecules of water? How many molecules of water are in that glass? It's a number that escapes our imagination. We can calculate it. There are ways to calculate it. It's an enormous amount of molecules. But we have to feel that number. And this is the analogy. If you see all the oceans on Earth, all of them, the Pacific Ocean, the Atlantic Ocean, the Indian Ocean, all the oceans, all the water on the surface of the Earth. And I ask you, how many glasses of water are in all the oceans on Earth? That is a number that we can kind of feel it, okay? You can imagine how many glasses of water are in all the oceans on Earth. And the analogy is this one. There are more molecules of water in that glass than glasses of water in all the oceans on Earth. Isn't that amazing that we have come to discover nature to that level? And yeah, it is something has been put together here. Where did that happen? It's an assembly of hydrogen and oxygen. Where does that happen and when? So, and these atoms, hydrogen and oxygen, where do they come from? Can we go inside them and see what is there? And then we come to the concept of science, of the evidence that we have today. We have a long discussion last night because Peter Doyle, I don't know if you have, he has come here. He's a very good speaker. He was talking about the dark energy survey and all these optical fibers that want to feed the lights of millions, literally millions and millions of galaxies to find out redshifts and to find out the expansion of the universe at different times, dark energy. So, we don't know. We know that this happened, we know that when happened, but we know very little. And we were pondering about what was before, where is it coming from? But anyway, and then we have to be careful because there are no answers here. And I don't know if there will ever be answers. It's difficult to say, impossible to say never, but it's a very difficult question here about the beginning, about the very origin. But this evidence that we have that the universe looked like that about 14,000 million years ago, and in a small fraction of a second, a billion, trillionth of a second, that energy starts to condense into fundamental particles, and these particles are going to be assembling to form the primeval atoms. We have the protons, the neutrons, and the electrons, and we are just short of 400,000 years after the Big Bang. We have the primeval chemistry, which is hydrogen and helium in the ratio of 3:1, that we can calculate and we can observe. So it's a very powerful explanation for this expansion of the universe. And then we have the formation of the stars from this cloud. After those, after that time, after a few 100 million years, we had the very first stars when the assembly of a nucleus of atoms, protons and neutrons continues. I'm going a bit fast in this because there is a second part of the lecture that I want to concentrate more. So it is in the stars that the nuclei of atoms are produced, assembled together. They are not created, they are assembled, because inside the stars the temperatures go to tens or hundreds of millions of degrees, and only then is when we can have this nuclear fusion, where we can have helium. For example, helium is with 2 protons, which are red, and there is beryllium, that 4 protons, 6 will be carbon, 8 will be oxygen. And then the process continues during the lives of the stars. Eventually the stars, very early stars, live very short lives. They're very massive and they live only a few million years or tens of millions of years, and they spread out all this material into space. And this is where we have the production of the chemical elements. This is another of the fundamental achievements of humankind, is to come to the explanation of the nature and the composition of the universe to this level, when we have all the possible chemical elements in the universe are here. The ones at the top left are the ones that are produced in the Big Bang when the temperature was still very high, but after a few minutes the temperature goes down. We have to wait for the stars to assemble all this in the nuclei of the stars, all the way down to 26 iron. The number means the number of protons in the nucleus, 26 protons. And then all the others happen, they're assembled during the death of the stars and afterwards. Only recently we knew, thanks to these experiments with gravitational waves, that 79 gold, most of that gold is produced by the collision. You know these things already, I suppose, of neutron stars. That's where the gold comes from, most of the gold in the universe. Amazing things that we have discovered. So, carry on. We are now moving only a few thousand million years from the Big Bang, and say a quarter of the age of the universe, we already have all the ingredients for life. The elements you see here in red circles are the basic chemical elements for life: hydrogen, carbon, nitrogen, oxygen, and phosphorus. We come back to those 5 elements later on. So at that point, 9,000 million years ago, when the universe is about 4,000 million years old, it's already able to produce solar systems like ours. So these solar systems are formed in a very well-known procedure now, because we have had the images from the ALMA telescope, for example, that can resolve this with microwaves. You can resolve these disks where most of the material comes in the center, it collapses, and then we have the high pressure and the high temperature that comes with that, where the nuclear fusion can start again, and then we have a star. Leftover material around will be, of course, hydrogen and helium, but also all the other compounds that come with the heavy chemical elements. And you see, and then we have rocks, and we have silicates and carbides that will form solid planets. And this is where the universe starts to be more interesting. By the way, well, let me just continue. Those solar systems, again, the stars are going to follow their process. They're going to exhaust the fuel. They're going to start to die. And when they die in different ways, I just put here explosion, but it could be a very gentle death. But essentially, those solar systems will be obliterated by the death of the stars, as it will happen with our own solar system in the far future. Then those dead solar systems are going to be recycling. The material is going to be recycled in order to produce new solar systems. And now we have the formation of our own solar system. And it's 4,566, more or less, million years ago. We know those numbers very precisely because of the analysis of the radioactive components on meteorites. So this is a picture of what the solar system may have looked at that point. And at that point, we have accidental collisions where the planets were getting bigger or they were destroyed, and they were all these kind of collisions. The case of the Earth was not an exception. We have a collision with another planet the size of Mars that collided with the Earth in a very special way, because they didn't destroy themselves. It was a kind of semi-collision, but enough to make the Earth bigger, and the leftover material will be our moon. Consequence of that collision is the tilt of the axis of the Earth, and the presence of the moon around the Earth with the gravity pull of the moon will keep that axis tilt constant, which is extremely important for the development of life in the long term, term. Now, a few 100 million years after that, we have one of the major miracles, I would say, when chemistry becomes biology. These 5 chemical elements we were talking about assemble themselves in 6 molecules, which is phosphates, sugars, and 4 bases. cytosine, guanine, thiamine, and adenine here. And those steps contain those 4 elements there. And outside in yellow, we have the phosphates. It's only 6 molecules, 4 bases and phosphates and sugars. That's all. It's a very simple molecule from that point of view, only 5 atoms. But the molecule is enormous. At that scale, that molecule will be the size of the solar system or something like that, because it goes and goes and goes. Because those bases here, they change in order. The 4 molecules here are going to appear in different orders, and that produces the genetic codes of all life on Earth. We had a lecture last week by Professor Mark Stelford. He's running a course for the first year undergraduates in the university, UCL. Life in the universe, life on Earth is called. And he said there are a trillion living species on Earth at the moment. Isn't that amazing? All that based on DNA. That's how amazing it is. So that DNA is encapsulated with membranes in cells that we call bacteria or prokaryotic cells, which are the ones that don't have a nucleus, and they appear very quickly in the formation in the Earth. The Earth was still a kind of greenhouse planet, very inhospitable, but nevertheless, we have life, and they have evidence for that life in microfossils recovered from Greenland, Australia. So when we see these green slimes in our beaches, some of that is made by cyanobacteria, blue-green algae that were very abundant at that time, and they had the property of photosynthesis. So these bacteria were in the primeval oceans that were boiling away because it was a very hot planet full of volcanic eruptions and electric storms. And in that process, there was photosynthesis, and the photosynthesis by this cyanobacteria that still continues today was managed to wipe out the carbon dioxide from the atmosphere, liberate oxygen, so the atmosphere became transparent, and that water that was on the surface of the Earth could stay there. And that was the creation of a paradise, thanks to the photosynthetic action of the bacteria, cyanobacteria, but it took 2,000 million years. In other words, it's more or less half of the life on Earth. It took since the formation of the Earth to today, half of that time has been bacteria producing photosynthesis. After that, we have the bacteria are going to come into cells which are far bigger, the eukaryotic cells. That means that they have a nucleus, they have a nucleus, organelles here, chloroplasts and mitochondria, etc. And these are the cells that really can make proper animals and plants that appear in the oceans at that time. We are talking hundreds of millions of years now only. So that creates a tree of life with a lot of branches there. Each of those branches will be metaphorically a living species. And then we have something that doesn't follow the laws of natural selection, if you like, the biology. We have physics now here coming and making a lot of, almost sterilizing the Earth by chance. We don't know if it was an asteroid or something, but the fossil record is wiped out at that point, 250 million years ago. And that tree of life recovers. The tree will be different. All that life that became extinct never comes back. But then we have new species that come, and from there we have the dinosaurs that were roaming on Earth for a couple of 100 million years, and that was very successful until very famously you know that another event happened, and this was for sure an asteroid about 10 kilometers across that landed in what today is Yucatan in Mexico and produced extinction of 80%, including the dinosaurs. By chance, all these things happen by chance. And we have to remember that. Even the formation of the moon, all by chance. The tree of life grows again after this extinction, and in the last 600 million years, we have the emergence of mammals that were repressed by the dinosaurs, and then the mammals have a chance to flourish and to continue developing until 300,000 years ago, not even a million years ago, we have Homo sapiens that has been on Earth since. And the rest of this talk is going to see what Homo sapiens has done on this planet. Isn't that a sense of humility? That is our position in the tree of life. And remember, that tree, well, there will be 1 trillion branches in this tree, according to what I said before. That means a billion branches. Now, the interesting thing now is this one, that when it comes to origins, that all humans come from this part of the world, from the tropical part of Africa there, between Kenya and Tanzania. Those are the oldest fossils that have been found, and there is a way of tracking the migration, I should repeat that, migration towards the west, going to Europe, migration towards the east, going to Asia, and that migration happens only a few thousand years ago. So, we have to remember this. Everybody listening here, everybody on this planet, in the past, in the present, and in the future, we are all Africans. And we have to learn that by heart. There is no question about it. This is all geological, anthropologically, biologically, genetically, whatever you call it, it's a fact. So there are no races. It's the human race. And we have to really put this into the schools and get rid of all these problems and all this suffering that we have today, because people don't acknowledge that. And see what happens. Those Africans that went to Europe 40,000 years ago, they came to Oceania, Australia, etc., cross the Strait of Bering, and they go and populate only a few thousand, 12,000, 15,000 years ago. It's nothing. Populate America. America is a continent. It's not a country. I am American. I was born in Mexico. There are 35 or more countries in America. In the United States, it's only one of them. So please, please say United States. Don't say America. It's very important. It is very important for us. In our schools, in all America, in our schools, we say Europe, Asia, Africa, America, Oceania. These are the 5 continents in the world. It's extremely important. America, right. So, those Africans that came to Asia 20,000 years ago and came and populated America here, we have in the Caribbean, the islands there. Those Africans that came from Africa a bit earlier and populated Europe, and then for commercial reasons, they took the ships only 500 years ago or something, and then came to find a new route to India, to the Indian continent. Instead of going around Africa, they wanted to find this route, and they found America in the way. 12th of October, that was last week. We were not exactly celebrating that. We just, it's a remembrance more. Those Africans that came from Europe and those Africans that came and populated America, they met in those islands. They failed to recognize each other. They re-encountered themselves after coming from Africa from two different ways at different times, and they failed to recognize each other. And that was a tragedy, because the Africans that came from Europe recognized that the place where the Africans that were there already in America, that area had a lot of richness, a lot of gold, rainforests, and today we know minerals, oil, precious minerals, precious metals. Desmond Tutu and Eduardo Galeano, a Uruguayan thinker, came to this description, which is extremely valuable. It makes you think. And that has been happening ever since, everywhere around the world. Everywhere. That gold that I symbolize here with 79 in the periodic table from collisions of neutron stars, there you go. That gold in this lovely mask by the Inca in Peru. And this is what happens when you fight for gold. This is what happens. These are brothers and neighbors. I mean, they were all Africans. They have the same ancestry. And we do these things for a bit of gold. And we keep doing it. And creating all this suffering. For what? All these people that are producing this suffering, they are going to die. They are not going to take that gold with them. So what is the point? I'm destroying the rainforest because below the rainforest there is gold, there is oil, there is minerals. And the rainforest itself has this richness. And you destroy that and you can plant your own plants, your soya beans and your palm oil. And by doing so, you have to kill the local population at the same time. This is happening right now in South America. Contamination of the water by chemicals, because the extraction of minerals leaves a lot of nasty chemicals behind. And a very interesting display here. Which are the rich countries? This is an island somewhere in the Pacific, I think, where no Europeans, no white people, so to speak, have been able to interact with these people. They refuse to interact. They are kind of isolated. It is an interesting example. I don't remember the name of the island, but look at this. This is exactly what we are doing with this lovely charity that we give them while we are extracting all the richness of these continents. For what? To contaminate, to produce plastic, because it's good for the economy. And this is the plastic bag that you threw yesterday. It appears here somewhere in Thailand. Banksy puts it very clearly. Very clever. So this is what's happening on planet Earth that took billions of years to develop, and that life and this paradise that we are destroying. In fact, we don't need the archangel to expel us from paradise. In this part of the Genesis, the Bible is very prophetic because we are destroying paradise ourselves. So that was paradise around us, and that's Adam and Eve left without the paradise that they themselves destroyed. So what are we going to do? What needs to be done? This is happening, and if we don't take control of this destruction of our lovely planet Earth, our lovely paradise, this is going to happen. If we don't take control, nature will take control, and that problem will come. First of all, we stop. We don't find ways to mitigate. We don't find ways to continue with the economy and then just greenwash everything. No, stop what you're doing. And now what are we going to do? Okay, we're going to get the plastic. Okay, let's think about it, but no more plastic. That kind of stuff. Let me just skip this a little bit. That is in Spanish for another lecture I gave. So the positive thing here, we have to take action, and this is happening especially with the young people. We know that character that is now, she's a young woman now, I think she's 20 now, and is still very active and fighting for a better planet. And it is in general the young people, most of them are women really, writing their books, and beautiful books, very well written, with a lot of love for the planet. A lot of sites that you can find in the internet of people working beautifully. This is a very famous wave of that Japanese artist, but this wave is full of plastic there, just to show the nasty thing we are doing. An ocean without plastic, this is in Spain, and this is in, again, also in Spain, and different ways of driving our lives without plastic. This is Ibelis Ramirez in a TED Talk about how to live without plastic. And this is interesting. Julieta Martinez, she's working in Colombia because one of the, and Marcela Fernandez in the glaciers in Colombia, where they were just saying how the glaciers are being destroyed. There was a very dramatic film the other day we saw. It was a festival called Blue Air Festival last week in East London. And they were showing these documentaries of the glaciers actually being eroded and they disappearing, which is the major diagnostic of the problem of our planet. All young girls working in Ecuador and South America mainly, because that's where the problems are. And these are education of girls mainly to sort out a lot of problems that we have with overpopulation, etc., that we have in our planet. There are so many things to cope with. So, and this is interesting. I don't know if you saw a lovely exhibition, a photographic exhibition in the Science Museum a couple of years ago, I think it was, of Sebastián Salgado. A fantastic photographer, black and white. He took pictures of the entire rainforest in Brazil, including the tribes and everything. And he and his wife have founded the Instituto Terra, which is a place where, and this is the website, I encourage you to go and see it because it is really, really interesting. This is what the Brazil mining place looked like. This is a horrible place. I think it was called Serra Pelada. It's a gold mine, which was excavated, and then by human labor, all these sacks full of mud, really, where we'll have a little bit of gold were excavated. Well, these kind of things were happening in the rainforest in Brazil, and he and his wife created this institute, and they are reconstituting it's not exactly planting trees. This is the before and after, but it's reconstituting the ecosystem, the whole diversity of species in the rainforest. And they are succeeding, and this is what it needs to be done. But of course, this is a miniature of what needs to be done in Brazil, but it needs to be done more of that. You see what's happening. That's the original rainforest. This is what the big companies are doing in order to get gold from that process. Beautiful pictures from the Instituto Terra. Okay, well, I'm going to finish now with a few things I have done recently. That was the March for the Earth, just before the pandemic in Trafalgar, in the Parliament Square. And this is my trip to Cuba this year, where I went with this project, the Paradise Planet Earth, to show in a congress, international congress of the didactics of the sciences, natural sciences, and the teaching of physics there. And I presented here in this amazing place in Cuba. The Minister of Science, Technology, and Environment has lovely programs. Tarea Vida, that means life work, is a lovely program for planting new species and planting and creating a biodiversity. All these are pioneer students in Cuba doing this work. And something that really called my attention was, well, of course, cleaning of plastic, all the places near Havana, near the port. But this is interesting. And there are several projects around the world. You know Jacques Cousteau from France. He founded a lot of things. Well, he invented the scuba diving. In fact, the name scuba was by him, self-contained underwater breathing apparatus. He invented the scuba diving, and his grandson is doing this. Coral farms underwater. And this is being done also in Cuba. So they are actually growing corals and trying to reconstitute corals. So not only on the rainforest, but also in the ocean. And it is working, but of course it's a minute scale compared with what is going on. So I went to a major university. That's my timeline that you may remember. I didn't bring it here because it will be too long, but that's my timeline. That's the formation of the atoms, that's the formation of the first solar systems, etc. And I'm giving here my presentation to students of the university in several places. The education in Cuba is fantastic, and it was fantastic. Well, this is University of Havana, and very interested. Well, the questions, the interaction with the students was really amazing. These pictures are, they show that. We have videos on that. And then I went to Mexico, my own country, where I took that globe and then made a demonstration I'm going to do for you now when I finish. Another thing to remember. And that links with the first slide of Camille Pizarro. Because education is so important when you bring the kids to the microscope and to the telescope, and you can see things that you wouldn't see otherwise, and you make drawings of that, and start thinking about what you think, about what you see. Assembling a telescope in Barcelona, one of these sky watchers, which are excellent. I have one, I use it all whenever it's clear. This was a 6-inch Dobsonian that we were using to look at the moon. In this case, was it Saturn? I don't remember, in Barcelona. And we take amazing pictures with those telescopes by just putting the mobile phone against there. You see the Apennines here, as I saw them last night. I think it was last quarter moon. We have Eratosthenes, Copernicus, Aristarchus. All these, we have Clavius here. Clavius and Tycho, whatever is Tycho there. And the kids need to see this in real life. So it is, if something makes us smile, that this molecule that contains those 4 atoms, carbon, nitrogen, oxygen, and hydrogen, has about 20 atoms there. Where do you put those atoms together to make chocolate or caffeine? Because caffeine and theobromine is very similar. Where do you put that together? In plants. Where are those plants? In the rainforest that we are destroying. So this is why it is so important. Now, I would like to have a little bit of light, please, to see where I'm going first. And then I want you to see this, this demonstration. The last step is bigger than the others. I know. Now look. This is 30 million times smaller than the real thing, the scale model. 30 million, more or less. At this scale, India, China, in the middle between China and India, the Himalayas. The Himalayas will be 1/4 of a millimeter high. If I put my finger, I will barely feel them. That's the highest mountains on Earth. Okay? So at this scale, the atmosphere, which is 90 kilometers high, 2 millimeters. That's the air we have there, 2 millimeters. At this scale, if I put a piece of paper in the Pacific Ocean, yep, the thickness of the piece of paper is telling me how deep are the oceans. So one side of the piece of paper is the bottom of the ocean, the other side is the surface. The thickness of a piece of paper. Now, the demonstration I want to do for you, and you are going to buy several of these. They are not expensive. You can buy them in the internet, as I did. And this is not the one you saw there, because the one I saw there is about this big. And it takes ages. I had to buy one of these electric pumps to pump it, but this is great. This is for big exhibitions anyway. So look what I'm going to do. I encourage you to do this. You take the lid of any bottle, really. All you need is something which is about a cubic centimeters of capacity. So I'm going to put some water here. And I'm going to drop on top of the earth about 3 drops of water there. That's equivalent of all the fresh water on Earth, rivers and lakes. Now I'm going to put everything. It's about a cubic centimeter. That's all the water in the oceans on Earth. So that's where life has appeared in the universe. From the bottom of the ocean to the top of the atmosphere, we are talking 100 kilometers. It's a couple of millimeters here. And the amount of water is this one. And look what we are doing with the oceans. Look what we are doing with the atmosphere and everything for the sake of gold or its equivalent. This has to stop. It is very easy to destroy this planet, and we are doing it very efficiently. It is easy because it is fragile, because it's very little of that. We may think there's a lot of water in the ocean. Well, it's not that much. It's a lot of atmosphere. No, it's not that much. We are finding plastic, microplastics in Antarctica. In a few years, there will be more plastic in the oceans than fish. So that is the story of the planet Earth. And this is something that we need to do something about. We cannot just stand there and, well, what can you do? That's life. No, there are forces doing that. And if those forces can do that, we can do better. Just finish very quickly with ancestral wisdom. Because the ancestral wisdom has the key to rescue our planet. The ancestral wisdom is telling us the beauty of our planet and the balance between nature and humanity. And we have the tribes from the North America, the Hopi, that they don't have the science, they don't have big religion, if you like, but this is a very good intuition. And they say, we dig precious things from the land, we will invite disaster. And certainly, it's true. And another one, well, if you see the inequalities of our world, this is embarrassing, really. I wish aliens don't exist. If we come and see this, there will be, look at this, I mean, the way we use water, when these people barely can have clean water, and we use perfectly clean water just to play and have fun. We have to change. And the state of life that we have is calling for another way of living, and this is what we need to do. But we, by mean we, is the everybody, not only a few of us. And that, again, a Hopi prophecy. Mediterranean, you can have cruise ships, you can have another kind of cruise ships where it just turns and then you have hundreds of people dying and drowning in the same sea. In the bushes in Africa, they have the concept of Ubuntu. Desmond Tutu was an advocate and Nelson Mandela as well. I am because you are, and you are because I am. I cannot be happy if the others are not happy. It's a kind of solidarity. We have to show solidarity. I'm not happy knowing that there are people being killed or starvation or all these things that are going on in the world. It's not my fault, but I feel something. It really makes me feel something. I cannot ignore that as a human being. It was Tolstoy, who said, if you have pain, you are alive. But you feel the pain of others. You are human. Some of these people meet you like this. I am another you. They realize we are the same, and you are another me. So this is the kind of thing that we need to put in our cultures, in our schools, and really embrace. This is the beautiful Pachamama in South America, Mother Earth, which embraces nature and embraces humanity. We have to come back to that. May sound a bit esoteric, a bit just kind of, I don't know, pseudoscientific, but it is not. It is very human, and we have to do it. This is what we need to preserve, and I hope we do keep it and make it flourish everywhere. Thank you very much. Thank you.
Anybody got questions for Francisco? It was a very thought-provoking talk, and I think many of us will go away thinking about what we've heard. Len?
Yes, it's a very good talk. Thank you very much. How we behave is key to this, and if we all behave differently, things will be so much better. But what about also the fact there's so many of us? There's 8 billion of us, and other animals are just a few hundred million maximum. How do you think that affects the Earth and its future?
Well, just the presence of that amount of people. I don't think it's the number of people, really. What is the problem? The problem is resources, and it's not lack of resources, because there are plenty of resources to satisfy a population twice that. The problem is distribution of resources, is concentration of power and richness. Because how come you can have 1% of those 8 billion people, 1% of that have, I don't know, whatever it is, and the Oxfam has these calculations, you know. This 1% has 90% of the wealth in the world. I mean, what? Going back to the aliens, no? They come and say, and what are they going to do? This 1% of people, what are they going to do? You want to be a billionaire or a trillionaire? Trillionaire now, that's the next. For what? Are you going to get eternal life with that? No. You are going to die. What's happening with your money? So that is the problem, is the distribution. We need a global power. A global, I mean, if you like, it's difficult because power corrupts and power is corruptible. But you need a kind of a global dictatorship in a way, like United Nations, but United Nations that really works with the assembly of the countries and deciding, no veto here, nobody has the power of veto. This is the whole community deciding how these resources are going to be distributed. That kind of thing. Yes, it's very easy to say, very difficult to achieve, but that's the society we have, and we have to fight. We have to be aware of that. It needs to be done. I'm happy with, if I had a full-time salary, well, I'm retiring, but if I have full-time salary at UCL, my salary will be about 50 or 60,000 pounds a year. I cannot spend that money. It's too much. And there are people that have, like David Miliband. He's the CEO of the International Rescue Committee. And they go where there are disasters, and you have to give donations of £5 a month, this kind of thing. What is his salary? It's nearly £1 million a year, okay? And this is a charity. And a lot of charities have the same. And then you say, what can I do with £1 million? What do you do? What do you buy? You have a solid gold house for a few years, and then you die. I mean, this is ridiculous. Because by having that house of £1 million or whatever, you have killed indirectly millions of people and starving children all over the world. See what's happening in Israel now, in Palestine. This is an absolute impunity. United Nations, nah. International committees, nothing. They just talk and talk and talk, nothing happens. Keep bombing, keep sending weapons, and until total extermination. I mean, it is ridiculous. But I agree, it is a matter of a power that takes control over the big powers, if you like, especially the United States. Will we see that day? I don't know. Yes, please.
Sure. If we do very little to improve the environment.
Sorry?
If we do very little to improve the environment over the next 10, 20, 30, how long have we got before something really bad?
The problem is that we are against time. And this very famous 2030 deadline for the global warming of 1.5 degrees or whatever. We have passed that already. We don't have long time. The destruction of the rainforest is happening as we speak. And by the time 2030, probably there is no rainforest left. So it is a difficult thing to do because, yes, it can be done, this global power and all that. It takes time. In that time, a lot of the population has been starved to death. We will have migrations from the south coming to the north. not by a few thousand as we have now, and there's a big problem already. There will be millions. The climate refugees will be millions coming. And we are not prepared. So, and that's happening in the next decade, I think. So we don't have time. It has to be done very quickly. It has to be a revolution in a way, very quickly and very drastic. Otherwise, the tsunami will catch up with us, and then we won't be able to swim away from the tsunami.
Still, what's the worst that can happen? Humanity gets wiped out, the Earth rebounds in a few hundred million years. No problem. We've been hit by giant asteroids.
Well, yes, that's right. It's a way to put it. I mean, it's yes. If you think about the Earth, and then you say, well, the Earth is here, and then it's thinking, oh dear, these human beings are a pest. I mean, they're destroying the rainforest. It took me so many billions of years to produce the eukaryotic cells and the trees of life and the extinctions and all that. I wish we could get rid of them. Well, they will get rid of by themselves. They will destroy paradise. They will get rid of that. And then the Earth will say, right, where are the dinosaurs? Let's start again. That kind of thing. Yeah. Because we
very egotistical vision.
self-extinction. Yeah. Which is sad. But
Sad for you? Yeah.
But yeah.
Sad for the universe?
The universe doesn't give, I mean,
Doesn't care, right?
you see, I should show you the pale blue dot, the picture of Carl Sagan here. Look, that could disappear. I mean, our entire galaxy can disappear from the universe. The universe doesn't give, I mean, there are thousands of millions of galaxies. I mean, it's nothing. Oh,
No, I've lost what I was going to say.
oh, sorry, that was my fault.
Oh, I know what it was now.
It will come, yeah.
The evolution of intelligent and technical life will eventually kill off the species. Do you think that has happened on other planets, exoplanets, and places in the universe, where the population actually just
Well, look, I mean, I
goes
have,
full circle and kills itself?
yes, I should revisit that lecture of the aliens because it has been updated because I gave it, I didn't realize, in 2012, was it? Yeah. We are talking 12 years ago. The bottom line of that talk is that there is no alien intelligence in our galaxy apart from us. As simple as that.
Or we'd have known.
Sorry?
Or we would have known. They would have let themselves.
The evidence will be overwhelming. Would be overwhelming because look, our solar system comes in the last quarter of the age of the universe. But in the first quarter of the age of the universe is all solar systems all the way through. Okay? So following a process which is very, very prolific in creating protoplanetary disks and things. So they will be, the chemistry is there, everything is there for these aliens to appear and to do something, to produce all kinds of technologies you can imagine. But there will be millions of them, not one, millions. So we will see spacecraft coming from 2 million years ago, from 3 million years ago, and then we couldn't see the sky because of the spacecraft. And all the history of the Earth, if you look at the geology of the Earth, there is not a single hint of alien intervention. So the absence of evidence is evidence for absence, and which gives us a very enormous degree of responsibility, because if we kill ourselves, that's it. There is no chance there will be any other intelligence.
Maybe the other intelligences have already committed suicide by killing themselves through the same process.
Well, but you're talking about, I mean, I'm talking about millions of civilizations.
Yeah.
Okay, some of them will kill themselves, some of them not. I mean, you have plenty of a statistical base to do whatever you like. Yeah.
Expect something, yeah.
So our destiny should be to become a spacefaring species.
Well, eventually.
Spread consciousness throughout.
Well, yes. Very slowly. If we go the way we go, again, the ancient, the ancestral wisdom in Africa said, if you want to go, hang on. If you want to go fast, you go alone. If you want to go far, we go together. And we need to be together to go far. If we go fast, we kill ourselves in the process. You are isolated. You have the power of the people, the union of people. So, yes, we have to explore the universe as in television, I have problems. Sometimes I have a lot of discussions with the interviewers that they say, well, you see, I had a problem last time. I thought they were not going to call me again. And they did this morning, but because of these astronauts that came back and all these problems with the Starship and all these things. It was the billionaire that had a spacewalk. Remember? He comes out of and then that's it, spacewalk. And I don't know. And then the interviewer asked me, well, you think this is a one-off or it will be more? And I said, I hope it's a one-off. This is not the way to do it. We cannot have, just because somebody has a lot of money, they can go to the moon, they can do whatever they like with absolute impunity. It's a bad example. It's creating more inequality in our world. That didn't go down very well, but that's what I think. But it has to be done by international collaboration, by international space agencies. Yes, the private sector is part of that. It has always been for NASA, but it has to be a regulation, a very strong regulation of these activities. Imagine, I mean, Elon Musk, honestly, but
he's making more progress in 10 years than the collaborative space agencies have achieved in 50. That's one man with a concentration of wealth which is dedicated to achieving.
Well, not exactly. I mean, he's building on experiences from the past, okay? So, but it's not the way to do it. He has, well, he's helping a lot NASA, yes, because he's keeping the space station alive with all these Falcon rockets. That's great.
And you have to ask yourself, why didn't NASA follow this route? And it's because it's a big collaborative system. Because
to go far, we go together. Elon Musk will never, ever, I can tell you this, he will never, ever go to Mars. Never.
Okay, do you want to bet?
By himself. I can bet you.
How much?
Will you tell me?
I agree.
You don't know that.
They don't have a clue.
What's your view?
And they have put 100 people in the space, what is called it?
Okay, that's a different
100
question. You
people.
said you will never go to Mars. That's a very strong statement. How do you know that? He's achieved great things. No one would have said the stuff you said on the screen here just now, of the stuff happening. 5 years ago, people said impossible. NASA did say it was impossible. He did it, okay? So let's not say these things are impossible. You don't know that.
Going to Mars is a different thing. Even to the moon. They want to go to the moon by 2030. I mean, the Chinese, the Chinese have a very slow pace, but they have their own space station. They have the largest telescope in the world. They have amazing technology.
And they share with us.
Sorry?
And they share.
And they share.
They share their data with us.
They have sent spacecraft.
Sorry?
It's a 2-year delay before they release the data. They keep it.
No. They brought the samples from the far side of the moon, from the Aitken Basin. That was I was on television for that one, and it was amazing. And they recovered nearly 1 kilo, brought it back. And you see the Chang'e 5, the one that landed near the Sinus Iridium in this side, it was a small replica of the Apollo. It was a lander, you see it. It had a lander, it had the orbiter, a lander, and the lander drilled 1 meter or 2 meters deep, recovered samples, very valuable samples, because this is most recent basalt on the moon, put it in the ascender, and then put it there, all robotic. You can see this little capsule going from one spacecraft to the other one, boom, there, lifts, joins with the other one, which is in orbit, and then comes back and lands in Mongolia. That was an amazing achievement. So, yeah. But they did it on their own, because they are forced to do it on their own. They have built, have you seen the Chinese space station? Have you seen the pictures? Look at it. You can Google it. Chinese space station inside. And it is all immaculate, it's all organized, and they are doing the experiments. They have a, but of course we are not supposed to know these things. But they have to do their own space station because they were not allowed to go into the International Space Station. But anyway, I think one day we will have all space agencies in the world united, including Elon Musk as part of that, and then we can go together and mitigate risks, because that was the point of my point today in the interview, that we had the failure of the Starliner, and then we have these 2 astronauts stranded there in the space station. They have to be there until February. But then we have the collaboration and the way to mitigate, because we have more resources. They didn't call the Soyuz spacecraft because they have Soyuz as well that could ferry astronauts up and down. I mean, today a Russian astronaut came down with the SpaceX, the Dragon crew.
So your metric, Boeing are the most successful space company because they.
Sorry?
On your metric, Boeing are the most successful space company because they've had more resources.
Well, but
because they got all the resources.
they have a little failure there of the thruster.
Collaboration, working together, no progress or poor progress. In fact, Starliner is a failure, really, isn't it, compared to SpaceX? Because they were on their own, and the SpaceX the same. If they keep going, there will be problems, serious problems. But anyway, I think we need to be more together. And that's against our society. Our society is not about cooperation, it's about competition. And competition is destructive, doesn't work. Competition destroys the rainforest, competition kills people. And collaboration is what we need, certainly.
Okay, so I think on that note, we'll thank Francisco.
Thank you.
I know he's got a train to catch, so I think if we move on from that, is everybody happy then? Yeah, great. Thanks again, Francisco. That was really
great.
It's a pleasure.
Thank you very much for your patience. Thank you.
Okay, good evening, everyone.
Just put the lights down then.
Now for something completely different, as they say. Yes, so I'm going to talk about Starship, the 5th launch, and a general update on this system. I've wanted to say a few words about Elon Musk. On the one hand, he is a genius. He's revolutionized the electric car industry and access to space. However, on the other hand, actually I won't read what I've written here. He's a bit of an awkward person. He's supporting Trump. He's saying things about the UK. So I struggle with that because I've always thought he was brilliant. And the only way I can cope with that is to think of him as 2 people. I can respect and admire the person, the scientist, and I just have to forget about the other person. Sorry, that's not science, but I just felt I needed to say it. Okay, so let's talk about the Starship concept. Here's the complete ship on the left, and it's the biggest, most powerful rocket ever built. It's 9 meters in diameter, it's 121 meters tall. That's well over twice the height of Nelson's column. The top section in the middle is designed to service the Earth, the Moon, and Mars. it should be able to independently land on all three of those bodies. It's also designed to independently take off from the Moon and from Mars. That's what it was designed to do. But on Earth, it needs the Super Heavy booster shown on the right. The Super Heavy booster has 33 Raptor engines, and the Starship has 6. The 3 in the middle are on a gimbal, and the 3 outer ones are designed to work in the vacuum of space. As was mentioned, the Starship has the ability to carry 100 people. I don't know if it ever will carry that many, but this just shows you how enormous this system is. So everything about the Starship is new. The Raptor engines are fueled by oxygen and methane rather than hydrogen. As you can see, they've gone through a development program looking much neater each time. The latest engines produce 230 tons of thrust. That's over twice the thrust of the Falcon 9 engines, the existing spacecraft. So let's just briefly mention the first 4 launches. So the first launch was so nearly a complete disaster. Several of its Raptor engines were damaged, but it was in fact impressive that it still got off the ground and towards space. The launch site was destroyed effectively by throwing concrete all around, and both vehicles were also blown up before they returned to the ground. So the second launch, before the second launch, they made 1,000 modifications, including changing the rocket direction control for electric motors from hydraulic and using water jets to protect the launch site. So the second test flight was partially successful, with all 33 of the engines lit and the launch pad wasn't destroyed. But then both stages blew up prematurely. The third launch was okay, with all 33 of the engines firing properly again. And they were able to do a few extra tests on testing payload doors. This picture is on the re-entry of the Starship into the atmosphere. You can see the red fin starting to glow red hot. The launch appeared to go perfectly again. However, it was shortly after this point that the engines on the Starship failed to restart and it broke up before it hit the ocean. The Super Heavy booster also blew up, and before it managed a dummy landing in the sea, it lost control as it entered the thicker part of the atmosphere. I was disappointed. I have to admit that at this point I was beginning to wonder if this system would ever be successful, and there seemed to be some fundamental problems. Then we had Launch 4. This was much better, even though one of its 33 engines failed. The Starship survived re-entry and did a successful dummy landing in the sea. Even though its guidance fin overheated, and also the Super Heavy booster performed perfectly, doing a dummy landing again in the sea. So I regained a bit of hope at this point. Then we come on to this final launch just over a week ago, the 5th test flight. The launch went perfectly with the Super Heavy booster taking the Starship to 40 miles high in the atmosphere. The Starship then, instead of just going into space and coming back, it went into orbit, a single orbit, then it re-entered the atmosphere and did a perfect dummy landing in the Indian Ocean. This time its fins survived the heat of re-entry. After the 4th launch, they increased the thickness of the tiles and made a few other changes. So that was extremely good. Then for the first time, they attempted to catch the Super Heavy booster. Okay, I'm going to play this. Yes, you can hear it. Listen to the BBC guy at the end.
13 of those Raptor engines, and this view is incredible right now. You can see how fast this vehicle is moving on the left-hand screen. Landing burn. We're
now down to 3 Raptor engines. We can see those chopsticks now
Hello, we've just witnessed history. Oh my goodness, they've done it. They've done it first time. That was absolutely astonishing.
Yeah, it was one of the most amazing things I've ever seen, I think. And I want to just play that again. I was going to turn the sound off if I can find a way of doing that. Yeah. Now, about there, right, now you've got to realise that at this point here, it's going at twice the speed of sound. They said it's coming in hot. They really meant it. I've seen other videos with tremendous sonic booms coming down. So it's incredible how fast that was coming in. And again, a little bit further on, it goes through the single sound barrier. It's a massive vehicle. When it's fully fueled, it weighs 4,000 tons, this super heavy booster. When it's empty, it weighs 200 tons. So this is nearer the 200 tons end. And it's coming in at this incredible speed and actually being able to control that from the first attempt. As I say, it's one of the most incredible things I've ever seen. I love it at the end as well, when it just comes down so very, very slowly and lands so carefully. You've got the speed on the bottom left. There, that's about the speed of sound, single speed of sound. Now, so it's slowing down in the atmosphere. The bottom of the rocket was red hot just through friction. Then it started its inner engines and massively, quickly reduced the speed. It's down to a very slow speed now, 100 kilometers per hour. But how it does this without hitting the tower, I just hope that's not a one-off. And then that last few feet, so virtually still. It's incredible. I'm an electronic engineer, and how you make a control system do that, I just don't know. Of course, this is all about reusability and cost to get a quick turnaround. No lives are at stake here. If this bit fails, it would just mean it would cost more to build one again. I was skeptical that it would work, but now I really am very positive about this system coming forward and dominating all access to space. Take a couple more years, a few more years, and it's going to be an amazing system. On the next test, they will try to land the Starship. On the Moon and Mars, that will land on legs that are yet to be attached. But on Earth, like the Falcon 9, but on Earth, I believe they're going to use the chopsticks again to catch the Starship. They're building a second tower in this location now so that they'll be able to catch them both. And that's the news.
Very much, Len. Well, as ever, that was very interesting indeed. So thanks, Len, for that. And we'll just carry on with the next part of it, which is Richard is going to take us on a tour of the night sky on the Stellarium.
Okay. Well, when I left the meeting last month, I went home, had a cup of tea, and went out and had a look at the stars, and struck myself at a beautiful, clear night. Had a look around, looked at a few things, and had a look at Saturn and other objects. And I actually saw Jupiter, which was rather nice. Get rid of some of these. Don't really need that. At the moment we've got 2 bright planets in the night sky, and you can see a fair amount of detail on Jupiter. In fact, you can look at them. My idea is to look at look at Saturn first, and then move over to Jupiter, because Jupiter is rising, whereas Saturn is actually heading towards the west. Now, people wonder why I bang on about looking at things and doing this. I do that because my idea is that if I get people and they really have a good view at Saturn, they'll remember that. It's the one that you see yourself with your own eyes that is the one that you're going to remember for the rest of your life. I can still remember mine, and it was in 1967. So I can still remember what I saw, which was roughly similar to what I saw this time, because Saturn's rings are now closing up. Next year they will be edge on to the Earth, and this means that Saturn's rings will virtually disappear. So this year is the last time to actually see them as a thin line of light. And if you focus your telescope very carefully, you should be able to see the gap between what they call the ansae, the handles, the little bits of dark sky between the ring and the disk. So that's something that you can look out for, and it's something that I actually saw with great clarity on Monday this week. I saw a beautiful image of Saturn with my little 4-inch short focus refractor. It's not brilliant optically in the sense that it's short focus, but it gave me a nice view. Then, of course, we can turn on a little bit further in the night, and if this will let me to do it, we come to Jupiter, which is rising in the east. It's actually a really bright star at the moment in the east, and of course it's climbing. And I had a look at Jupiter on Monday, and to me the markings are not very distinct. They're quite faint. But the trouble is, I've always been used to looking through an 8.5-inch telescope, so to be honest, it's going to be faint. The markings are not going to be quite so distinct. One of the things I noticed particularly, and it's becoming increasingly common, and I think images will bear me out on this, that actually the red spot, the great red spot, which has been around, we know observations by Cassini and others in the 17th century, it's been around an awfully long time, is actually really almost beginning to disappear. I could barely make it out in just to the one side of the polar side of the south equatorial belt. I could just about see it, and it was right in the middle of the disk, which means that it's actually not not a very easy object to observe. If you've got a good telescope, you should be able to see it, but anything that's smaller than about a 4-inch won't actually show the great red spot, which is a complete opposite of when I started observing. The great red spot was brick red. Now it's just sort of, it's kind of grey sort of beige colour. So that's a couple of things that you can look out for, and you can also image them. That would be another thing, wouldn't it? Now, one of the things that's often said about the autumn sky is that it is very, very plain. It's dull. You haven't got the bright stars of the summer, and the ones that are really bright in the winter haven't really got a chance to rise by then. But actually, there's a lot of things in the sky that you can have a look at that are really interesting in this area. Now, the area that I'm talking about is the area, yeah, got it. It is the area around Perseus and up to Cassiopeia. Now, there are some beautiful clusters in this area. For a start off, you've got, this is Perseus, this Y sort of shape of stars, that's Alpha Persei, and the association stars there, the cluster that accompany the star Alpha. Up here we have the double cluster. Now, one of the things that I've noticed is that through a telescope, the view is getting more and more dull. Telescopic views are disappearing, and I think that's largely due to pollution and the amount of light, which is rather frightening, really. And one of the things that doesn't get mentioned very often is the pollution of space itself by all these bits and pieces of satellites that are floating around, which are causing problems to radio astronomers and optical astronomers now. So we don't only pollute the planet, we're also having a go at space. Anyway, double cluster is really attractive. It's a beautiful cluster, best seen in binoculars, really. And also down here, if you use this star here, this is Algol, this is Beta Persei, and that is the famous star that actually is the first variable star that was actually noted. It's an eclipsing binary actually, and it has a very regular period, and that's where we get Algol from. It's actually literally the ghoul, the ghost, the evil spirit. It's got its name. Although actually that actual variability wasn't noticed until the 16th century. So it was rather strange that the Arabs should have given it that particularly morbid sort of connotation. But if you use that star and this one here, which is Gamma Andromedae, between them there's a cluster called M34. Now that is useless. In a low power on a small telescope, it's beautiful. There's there's bright stars, double stars in a particular geometric shape, very attractive. In binoculars, it's actually much better. So if you've got a pair of binoculars, any size will do, and have a look at that, that's a beautiful sight you can see. If you've got a telescope and you move over to Gamma Andromedae, that's a rather nice double star. The colours are a golden colour, which is the main star itself, and it's Comes, that's what they call the companion in a double star system. That actually is a sparky blue colour. I know that it's colour contrast, but nonetheless it's really attractive. So if you've got a telescope, that's a good sight to look at. And of course, there are other clusters in the same area. Now we are coming up at the moment. This is Capella, and this is Auriga. This is the constellation of Auriga. There's the three kids that mark star Capella, which incidentally is an F-type star. And actually, it's strange. It's actually a binary star, spectroscopic binary discovered by spectroscopy. That actually consists of two components. One of them is an F-type star, which means it's slightly orangey or slightly yellowy, and a G-type star, which is like the sun. So down here we have, in this area here of Capella, of Auriga, we have three clusters. They are M36, M37 and M38. They can be seen in binoculars. In fact, I've now found that trying to find them in a telescope is really tricky. Whereas if you've got a pair of binoculars, you can actually have quite a nice view of them all at the same time. So you get the combined effect of three clusters, and it looks really good. So for binoculars, because the sky is so poor at the moment, binoculars are actually better than a telescope for looking at clusters like that. So you've got, so as I say, you've got M34, you've got M36, M37, M38 to look at. That area of sky is particularly attractive. And of course, if you get tired of that and you really want something straightforward and easy to see, you can always have a look at the Pleiades here. And one of the things to notice is there's a little group of stars, 7th magnitude, that make a slight sort of tick shape in the lower part of the cluster. They are really obvious in binoculars, and it's sometimes called the hockey stick, but they are 7th magnitude, so when you look at those, you know that your binoculars can see a star of the 7th magnitude. You should be able to see down to about 9. So that's really all I want to talk about this particular month, but there's plenty to look at, really is, believe me. It's a really interesting period, and the reason that, as I say, I'd like to tell you about these things you can look at is that imaging is really good, but the things you often remember are the things you actually see, and it's live. And one of my ideas is that eventually people will get tired of me saying this, go out and have a look, and fall in love with the sky, and actually be worried about the fact you can't see it so much now. So that's my scenario here, and I'm sticking to it. Okay. Next one.
Thank you very much for that, Richard. And with that, we reach the end of our evening, albeit for refreshments. So thank you all for turning out this evening, and we appreciate you being here. We will attempt to make the recording available as usual on the YouTube website for anyone else that wants to watch it or revisit any of the things that we talked about tonight. So thank you again, and enjoy the rest of the evening.